In this lecture, we will learn how to assign the dead load, live load, and wind load to the this banner supporting structure or signboard. So first of all, what we can do here is that we can draw a shell structure here, and on that shell structure we can assign the wind load. So what we need to do here is that we can go to define section properties and slab sections. We can left click on add new property. Name the section here as let us say 10 mm thick shell. So we can enter the slab material as Fe250 and enter the thickness as 10 mm. To account for the self weight of all the banners and all its supporting arrangement that can be applied on this. So this itself will act as the self weight. So what we can do here is that we can go to draw floor wall objects and draw floor and wall. So we can enter the property here as 10 mm thick shell. So now we have entered this property here. We can go to check model to check that whether we have done the modeling correctly or not. So the modeling is correct, and after that we need to assign the wind load. So what we need to do here is that we need to go to assign shell loads and uniform. So here we need to select the WLY and direction as global Y, and enter the wind load as, let us say, 1.8 kN per meter square. So left click on apply. So now 1.8 kN per meter square load will be applied on all the shell along the global Y direction, and for WL minus Y the sign shall be opposite, that is minus 1.8. And similarly for this along X and minus X, what we need to do here is that we need to go to assign frame loads and distributed. So first of all, for dead load we have accounted by this shell structure. For live, what we can do here is that we can assign some point loads over the top of this to account for if a person will stand here. So to account for its load, what we can do here is that we can assign a uniform live load of the code guides us that for inaccessible structures the live load shall be 75 kg per meter square, that is 0.75 kN per meter square. So we can multiply 0.75 into 0.8, that is 0.6 divided by 2 for both of these frames. So 0.3 kilonewton per meter UDL will be applied, which is very less value. So direction has to be gravity and the load case has to be live. So now we have applied 0.3 kN per meter of live load. After that, dead is covered, live is covered, and now we have to account for WLY, that is wind load along this direction. Wind load that is coming on this part is automatically accounted, but to account for this part, what we need to do here is that, let us say the wind value is coming out to be approximately 3 kN per meter on all of these members, after accounting solidity ratio and after accounting for the openings in the banner. So we can apply 3 kN per meter of live load, and direction of load application has to be global Y. Let us say we reduce it to approximately 1.5 only, because 3 kN per meter is very high. So to account for the load here, we have applied this value, and on the upper we have applied 1.8 kN per meter square flow loading along this global Y direction. Similarly for WL minus Y, opposite shall act. So we select the same members here. What we can do here is that we can go to view and show selected objects only. And apply minus 1.5 to account for the reverse wind. And for WX, the wind load shall be very less, so we can apply approximately 0.75 kN per meter along global X direction, and minus 0.75 for WL minus X. So now we have applied all type of loadings on the structure, that is wind load as well as seismic load. Now we need to define the response spectrum load case also. So to do that, we need to go to RSX and load case type as response spectrum analysis. We need to add acceleration U1, function as IS1893, and again, as I had repeated in the previous lecture also, that the unit has to be changed. So we change, let it remain it like this, and left click on OK, and then again left click on add new case and enter RSY, type as response spectrum, and enter load case as U2. So function as IS1893, and then left click on OK, and then again left click on OK.